All right, let's actually talk about uh this assignment. It's mainly on conceptual circuit questions. So this really isn't like a lesson in of itself. It's more of like an assignment to see whether or not you truly understand the concepts, right? So number one says which circuit has the largest equivalent resistance. So which circuit has the largest equivalent resistance? This is how you're going to think about it conceptually, right? So in the answer choices, you see series circuits and parallel circuits. So first step is identifying, well, is it series circuits or parallel circuits that give you the least total resistance? And I gave you this analogy in the parallel circuits lesson, right? So the more pathways that you have for electrons, the the less bottlenecked those electrons will be, right? If you add more escalators for these humans, the more humans can travel through this path. And if you decrease the amount of escalators, let's say we're all forcing all these electrons now. Let's say we close down both of these escalators and we moved everyone, and now everyone can only use this stairway. You've now bottlenecked the amount of electrons. You've now bottlenecked the amount of electrons. So the least so the more resistors you have in parallel, the more pathways that you have, the less resistance there will be. But if you decrease the amount of pathways, the more resistance you will have. The more resistance you will have. So if you only have one pathway, which is usually how series circuits operates, if you only have one pathway, then you've decreased the amount of then you've increased the amount of resistance and you decrease the amount of electrons flowing through. So here's one thing you want to remember, right? When you're looking at these problems, series circuits usually greater resistance than have more resistance usually have more resistance and parallel circuits less resistant less resistance. Let's actually have more resistance and parallel circuits have less resistance. All right. So again, in the problem, you want largest resistance. So that automatically rules parallel circuits out. So you don't care about B. B and D are both wrong. So it's either A and C. It's either A or C. It's either A or C. Um, and you know that in series circuits, equivalent resistance is R1 plus R2 plus R3. So R EQ is equal to R1 plus R2 plus R3. So choice A has 2, choice A has 2 and 4, and then choice. So this is for choice A, right? So you get 8 ohms here, and choice B, or rather choice C. Choice C is 2 plus 2 plus 6, and you get 10 ohms, right? So choice C is your answer. Choice C gives you greatest greatest equivalent resistance. Now number 2. When only one light bulb blows out, an entire string of decorative lights goes out as well. The lights in the string must be connected in what? Okay, so must be connected in what? Now, let's actually, let me take a look at this. Now, if you take a look at this thing right here, if one light blows out, I want you to take a look at the bottom. If one light blows out, right? If one light blows out, Even though only one light blows out in a parallel circuit, there are other pathways, right? Electric current can go through here, can go through here, can go through here, and every other single light will still work. So it's definitely not parallel, because what the problem is saying that when one light blows out, all the lights, the entire string of decorative lights go out, so it goes out. So it can't be parallel. There's no way it can be parallel. The other option, the other options are a series, right? So it's either choice C or choice D. Choice C says series with one current pathway, and choice D says series with multiple current pathways. And what that means, so series with one pathway is this right here, right? This top part right here. This top part, that's a series with one pathway. So if one light burns out, then the entire electric current, there's no more electric current. Because if one light stops working, electric current can't pass through it anymore, which means that it will not work anymore. So the entire thing goes out. So it's going to be choice C. What choice D is saying, series with multiple current pathways, it's saying this. This is a series circuit with multiple current pathways, right? So even though, even though, let's say a light burnt out on the top string, then the entire line will go out, right? The entire line will go out, but not the rest of the line, not the other strings. The other strings won't go out. The other strings won't go out either, because there's a different current pathway. Only this top string will go out if one of these light bulbs burn out, but not the rest. So it can't be D. It can't be with multiple current pathways. If one pathway gets burned out, if one pathway starts working, the entire string will go out. And so it's going to be C. So let's move on to number 3. So which combination of resistors has the smallest equivalent resistance? Again, you know your series, if you're connected in series, you have the greatest. Yeah, well, I mean, you don't have greatest resistance, you have greater resistance. So greatest resistance. And so parallel give you smaller resistance, right? It gives you smaller resistance. So you can automatically rule out choice A and D. So choice A is automatically wrong. Choice D is automatically wrong as well. So it's either choice B or C. Well, clearly choice C has the lowest resistance because it has 1 ohms, and 1 ohm is less than 2 ohms, right? So it's going to be choice C. But if you want to prove that mathematically, if you want to prove this mathematically, well, let's actually do the resistance equations, right? So this is 1. So this is for B, and this is on your parallel circuit, right? Because we know that in a parallel circuit, this is the formula for total resistance. And so you have 1 plus 1. Again, I'm doing 1 over 2 because the resistance in choice B is 2, right? The resistance of the resistors is 2 ohms. So you get this, get 1, 1 half plus 1 half is 1. So 1 over Req is equal to 1. And so Req is just 1 ohm. It's 1 ohm. In choice C, you have R, this is equal to 1 over 1, which is just going to be 1, right? Plus 1 over 1. And this is actually just going to be 2. So 1 over Req is 2 times Req. So times Req. So this cancels out. So you have 1 is equal to 2 Req divided by 2 and you get 0.5 ohms. 0.5 ohms is equal to Req. So clearly this is less, right? We figured it out. Clearly. Clearly. All right. So it is a choice C, which proves that we were right. So again, you don't really even need to do math for this. You just need to just realize you just have to have concepts. You have conceptual understanding. Which circuit has the smallest equivalent resistance? So smallest, again, you want to get smallest, you want parallel circuits. Parallel circuits give you the smallest resistance. So it's gonna be either choice A or choice C. Because choice B and choice D are series, so those can't be right. So it's either A or C. A gives you, and C gives you more pathways, right? Because if you think about it, more escalators, more people can travel through. So the more pathways you have, the least resistance. So more pathways, lower resistance. More pathways, lower resistance. So the choice is C. So choice C is the answer because there's more pathways. Again, think about it. More escalators, more people can travel through, less resistance. So it's going to be C. And you can obviously prove that using math as well. In which circuit would current flow through resistor R1 but not resistor R2? Actually, I can demonstrate this using a FET, to be honest. Um, right here. So basically, if I close the switch, let's actually decrease this resistance right here. Sure. If I open the switch, this current right here on the right hand side stops working, right? No more electric current can flow through this light bulb. But if I connect the switch now, if I close the switch, electric current can flow through. Open it, electric current cannot flow through here. Close it, electric current can flow through there now. But let's say I'm connecting it there. So if I open it here, in front of these two resistors, then no electric current can flow through the entire thing. Can close it, and then electric current can flow through. So again, it depends on where you're putting uh, the switch. So you want, it says in which circuit would current flow through the resistor R1 but not R2 while switch S is open? Well, A already looks correct because it can flow through R1. So if R2 has the switch open, nothing can work here. B is saying that if the switch is open, no current can flow through. Same thing with C. And D is saying that current cannot flow through R1 if switch is open because it's in front of R1. So, but you want R2 cannot flow through R2, and the choice is A. So, the answer is A.